Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at encryption. Encryption and cryptography in general is a rather large topic. However, Microsoft and PowerBasic have done quite a lot to aid you in this. Today we're going to add two new libraries. One library that ships with PowerBasic and one new library. This will make use of a DLL that ships with Windows called bcrypt.dll. What we will do first is to add the library that ships with PowerBasic. This is bcrypt.include, and the new library we're going to add today is this one, AES256. The one thing we need to provide to these encryption libraries are two passphrases, a data passphrase and an HMAC passphrase. We will use constants to store these values. Now, obviously the security of your data will depend entirely on the quality of your passphrases, so you want to pick a good long passphrase to be used. These are fairly short passphrases we're using, but they'll do for the work we have to do today. If we have a piece of data we wish to be encrypted, we'll need a variable to store it. Then we'll create another variable to store the encrypted version of it, and another variable to store the decrypted version of it, to make sure that what gets decrypted looks exactly like the data we put into the encryption in the first place. So we will create these three variables. strdata for the data we're going to be encrypting, strencrypted for the data once it has been encrypted, and strdecrypted for the data following decryption. Encryption is very often used to encrypt passwords, usernames, and possibly even server names and folder locations. What we have here is a very short string which we're going to encrypt. Now, in our new library, the AES256.include, there are two functions, one to encrypt and one to decrypt. First thing we're going to do is we're going to encrypt our string. So we're going to set an encrypted variable to be equal to the output from our funencrypt function. And in our funencrypt function, we're giving it three variables: the data we want to be encrypted and the two passphrases, the data passphrase and the HMAC passphrase. And the output for that will be our encrypted string. Now we'll need to test the output of this to make sure that we manage to encrypt it correctly. So if the function returns an empty length string, then the encryption has failed. Otherwise, it has successfully managed to encrypt the string. So what does our encrypted string actually look like? Well, let's put that out to the log. So if we run our program now, we'll see that there is our encrypted string appearing on the screen. Now it's using a lot of control characters and probably unprintable characters, which aren't easy to store in text files or in XML files. So we want a way of actually turning that encrypted string into something that can be stored in a flat text file. Now we provided two additional functions in the AES256 library, one to turn this binary string into a hex string, and one to turn a hex string back into a binary. Doing that allows us to store this in any flat text file, and even print it on the screen. So we're going to use the bin to hex new, and that will take our encrypted string and put it into hexadecimal. And there is our hexadecimal string. Now the acid test of any encryption is, can we turn that back into the original text? So having encrypted it, we will now attempt to decrypt our string. Quite similarly, we do exactly the same as we did before, the only difference being we're now calling the funcDecrypt function. We're passing it the encrypted string and the data passphrase and the HMAC passphrase. And we're putting the value of that into strdecrypted. And again, if we fail to decrypt the string, it will return an empty length string. So we will test the length of that string, and if the length is 0, then decryption failed. In this case, probably because one of our passphrases was incorrect. So we're testing the value. If it fails, we print decryption fails, and if it succeeds, we'll then attempt to put out to the log our decrypted string. So if we run that now, we'll see that it has indeed put out the "this is the data to be encrypted," which was the value of our original string. The other thing that's worth noticing is the value of the encryption. If we run it once more, we'll see that the beginning characters of the encryption are 9C88. If we run that a second time, you'll see the values change with each attempt at encryption. But we still manage to decrypt the string. So we're going to set two extra variables up now, which we can use to store the value of our encryption. We're going to use plain encrypted to hold the hex value of our encrypted string. And we're going to use the bin to hex new to store that. Now the plain encrypted value we can then put into a flat text file. And then having got that flat text file populated, at some point later in your program, you may want to pull the information out and turn it back into something you can decrypt. What we're going to do next is we're going to take that value in the plain text and turn it back into something that's encrypted. And we're going to use the other function in our library to turn it back. And this is the hex to bin function. And this takes our plain encrypted value and turns it back into its original encrypted format. So this will emulate what we will do in our applications. You will probably have the encrypted value stored in some initialization file or XML file, and then when your program runs, it will read the value in its plain encrypted format. You will turn it into its binary encrypted format and then decrypt it. So this should work quite happily. And there is our string coming out in plain text. So what we've achieved today is we have now the ability to take a plain piece of text and encrypt it into an unreadable format. We can then store that string in flat text files or in databases, and then pull it back at some point later and decrypt it into its plain text format again, where we can use it to access databases, systems, servers, or paths. This has been a short introduction to the Microsoft Crypto API. That's it for today. Thank you for watching.